On average, a commercial aircraft that's an airplane in commercial service gets struck once per year.
Imagine you are flying somewhere, half asleep or scrolling through your phone when the seatbelt sign turns on. The captain's calm voice fills the cabin. We'll be taking a slight detour to avoid some weather ahead. What that really means is there's a thunderstorm up ahead, and your plane will not be flying through it. But why not? After all, planes fly through rain all the time. So, what makes a thunderstorm so dangerous that pilots would rather go miles around it? A thunderstorm isn't just rain and lightning. It is a wild, violent system built on instability. Warm air rises from the ground, full of moisture, and cools as it climbs. It turns into these massive towers of clouds that can stretch more than 10 miles into the sky, sometimes even higher than where most commercial planes fly. Inside those clouds, air currents are moving in every direction, up and down at crazy speeds. It's like a sky full of invisible elevators, and that's what makes it so dangerous. These wild movements create what pilots fear most: severe turbulence. Not the light bumps that make your drink ripple, but the kind that can throw an aircraft up and down in seconds. Some of those updrafts can blast air upwards faster than a hurricane wind. Imagine trying to drive on a road that suddenly lifts into the air, then drops right back down. That's what flying through a thunderstorm feels like.
Lightning can be powerful enough to punch holes straight through the thinner parts of planes, like their wings or noses. But small holes aren't the main concern when it comes to lightning.
Planes are built to handle a lot. They can take strong turbulence, lightning, and even small bits of hail. But there are limits. Inside a thunderstorm, there's a specific type of cloud called a cumulonimbus. This is the real monster of the sky. It holds everything from water to ice to giant hailstones. Some of them can be the size of tennis balls. Those can crack windshields, dent the plane's nose, or damage sensors that the pilots rely on.
Back in 1963, for example, lightning went through a plane's fuel tank and caused an explosion that killed all 81 people on board.
Then there's lightning. Planes actually get struck by lightning more often than most people think, and they can handle it. The electricity usually passes along the plane's outer shell and exits harmlessly. But the danger isn't the lightning itself. It's everything that comes with it. The same electrical activity that creates lightning also happens in areas of violent turbulence and ice. That combination can cause serious trouble. Now, let's talk about icing. At high altitudes, the moisture inside clouds can freeze onto the wings and engines. When that happens, the aircraft's shape changes. The smooth surface that keeps it flying turns rough, and lift starts to drop. Even the engines can lose power if too much ice builds up. Planes have systems to prevent this, but inside a strong thunderstorm, ice can form faster than the system can remove it. That's when things get really risky. Another invisible threat is wind shear. It's a sudden change in wind speed or direction over a short distance. Thunderstorms often create powerful downdrafts that rush down toward the ground and then spread out in all directions. If a plane flies into one of those while landing or taking off, it can lose lift instantly. They used to cause deadly crashes. Today, pilots and airports have advanced detection equipment that can warn them in time. But it still remains one of the scariest weather events a pilot can face. And then there are microbursts. Think of them as smaller, but even more intense downdrafts. It's like someone dumping a huge bucket of air from the sky. When that air slams into the ground, it spreads fast and can push an aircraft down before it has a chance to recover. Even big jets can't fight against that kind of sudden force. Pilots are trained to spot the warning signs and climb away fast if one appears near the flight path. So when you hear your pilot say they're going around a storm, it's not just caution. It's because thunderstorms are unpredictable. They can grow, move, or collapse in minutes. Radar can track them, but no one can fully predict what's happening inside the cloud. Some parts might look clear on the screen, but inside, violent air currents could be waiting. That's why pilots stay at least 20 miles away from the edges of a storm. It might add extra time to the flight, but it keeps everyone safe.
Lightning never makes it to the inside where passengers and crew and jet fuel are. It gets stopped by the plane's surface. The process is known as the skin effect, and it's also the reason you're safe from lightning in a car.
You might wonder, with all our technology, can't planes just fly above thunderstorms? Not really. Some of these clouds rise higher than 50,000 feet. That's higher than any passenger plane can go. The air is too thin, and the engines lose efficiency at that altitude. So the only real option is to go around. It burns more fuel, but it's the safest move. Airlines also have teams of meteorologists tracking storms around the clock. They guide pilots through safer routes and send updates in real time. Pilots and air traffic control stay in constant communication, adjusting altitudes or changing directions when new storms appear. Every small decision up there is about keeping distance from danger. So the next time you are flying and hear that announcement about weather delays or route changes, just know it's not random. Somewhere ahead, there's a storm raging, full of lightning, hail, and violent winds. The pilots are reading every bit of data to make sure you never feel it. From your window seat, it might look peaceful, but above those soft clouds, nature is at full power. If you found this interesting, drop a like and tell us what part of flying freaks you out the most. We might just explain it in the next one.